So today, I hope everyone's happy and healthy and that we're staying indoors, washing our hands, getting enough to eat. And hopefully, everyone is still eager to learn, and we are back on our class instruction. So today, our mini lesson is on how to spot reliable information. So let's click present. So, when it comes to the internet, not everything we have is reliable, particularly if we are looking for adequate resources to support our research or a topic of interest. These are the domain names that I gave everyone in their packets. These are generally reliable sources. We can tell National Geographic is a reliable source primarily because one, it has a valid reputation in the science and geographic community, meaning that everything that they post typically is going to have scientific evidence behind them. And weather.org, as we saw yesterday in our video, typically will have a lot of charts, maps, numbers, statistics, things that are measurable and that we can view in real life. We're going to again go through our domain name. So, as I was saying, National Geographic, its reputation is renowned. If we look up National Geographic in a search engine, we're going to see names of doctors, scientists, organizations that typically have supported National Geographic and its cause. It's the same concept with our scholastics that we were using before the quarantine. Our scholastics will usually have scientists, diagrams, charts, numbers, everything that can be factually supported, or even if you looked it up, scholastic programs, Science Scholastica, you're going to see a lot of support for those organizations. We can usually determine whether or not a source is being genuine if we look up the author or the organization behind it. So, does the organization have a number of people with college degrees? Has this organization had people who had trained for a number of years? Have they explored the places they're talking about, conducted experiments? These are things we're going to want to look into, and it's just as easy as looking up somebody's name or their profile online. Here's a fact check. National Geographic, fact versus opinion. National Geographic has things we can observe that's true. So if National Geographic says that tundras are a place where there's a lot of snow and ice, if we look up videos and images of tundras or speak to people online or read testimonials from people who've been to tundras or even live in tundras, we can observe that to be true. We can also use an experiment to prove what is true. So if tundras are very cold, we can use an experiment, like at home, looking in our own refrigerator, making ice, going outside in winter to prove that cold weather exists, and so there are cold environments on Earth. And as I said, we can also look up credited sources to support the facts. So maybe you want to look up the scientist who wrote this article. You can look them up, see that they have a certain number of degrees and field time, meaning that they've been on this tundra. And also, we still have graphs, charts, pictures, and videos, things that are visual, things we can see, things we can read. So with our graphs, we got our XY charts, for example, or a pie chart, or even a pie graph. Fact check. Global warming is a result of CO2 buildup in the atmosphere. So we have read about CO2, carbon dioxide, building up in the atmosphere of Earth as contributing to global warming. I can fact check this. I'm going to look it up on National Geographic. So here's my link. And here it is. Our article is huge amounts of greenhouse gases lurk in oceans could make warming far worse. So here is my check. Looking it up by Todd Woody. I could also look up this name if I'm trying to think if he really is a scientist or not. By reading his article, I can see a lot of things are underlined. For example, carbon dioxide and methane. Those are two things that we're studying right now with this fact. So I'm going to click on these highlights here. Carbon dioxide levels are at a record high. Here's what you need to know. And this is by Christina Nunez. So usually we can tell when it is supported, when it's giving us multiple sources to look into, again, for the facts that it is supporting. We have other things outlined as well, about 3/4 of emissions, again, of carbon dioxide. Emissions was a word that we dealt with in our scholastics, so we do know the word emissions and CO2 is supported from our previous research. And here is the proof. In this article, scientific names and numbers are present. Carbon dioxide and methane are both scientific names for gases, certain gases. This article has results that can be measured and observed. So here we have numbers. Fuses are burning, about 3/4 of emissions, thousands of years, 84 times more potent over the 2 decades regarding CO2. So we can see that this article does use a fair amount of support. And if you also look here, this article was published last year. Looking up the date usually is important because if our article is over 10 years old, the results we're looking at may not be accurate for the topic we're studying right now. There could be new documents, new research, new videos, new documentaries, new scientific input on our topic of choice. Opinion. Global warming isn't real. We cannot prove it. That is generally considered an opinion. Look at the previous statement in our previous slide. We're fact checking, we're looking through the article, looking for names, we're looking for numbers, for things that are observable. This statement here is an opinion because it says we cannot prove it, when evidently we have things that can disprove this person's opinion. We look over the article, what we cited as observable evidence. Their opinion can be disproven. A fact is always supported through observable data, things you can look up, things you can see, things you can measure. An opinion does not need to be supported by facts. It's a person's thought or belief on the matter. While someone may not believe that global warming can be proven, scientists are observing it every day. So which website do we use? Understandably that we have to use other resources when we come down to our 3 topics and our final topic. We have to consider our domain names. So we have stated that National Geographic is a renowned source for scientific news about our world. We can look this up and it is supported. Despite its domain ending in .com, we have an archive of reliable, scientifically backed articles. So domain names play a big part in this. By domain name, I mean things like .com. So .com usually means that there is some sort of commercialization or someone's trying to sell you something on this website. So what does a commercial try to do? Sell you something. Its site fits what's being sold, so it may not be reliable. If we did see some advertisements in our National Geographic, things for curriculum, for science kits, so it's very science oriented. So if the website's trying to sell you something that doesn't quite fit the program of what you're looking up, it may not be reliable. You'll want to check the author of the article or look at the source of your diagram or chart. .org will usually stand for organizations, and organizations tend to specifically dedicate its information towards something. So, for example, with weather.org, it's an organization dedicated to the weather. This organization specifically dedicates its information to weather patterns, the daily weather, and of course, why certain weather conditions occur. .edu, we're all familiar with. We all have a cps.edu email. When something ends in edu, it's typically the domain of an education program, or it's a website that's trying to educate somebody. Colleges where a lot of research is done, such as you'll see Harvard University posting scientific articles, will usually end in .edu, and that is supported because an educational facility will usually have scientific backing to its information. And then, of course, we have .gov, which we saw with NOAA in our previous video. That means that is government-funded research or a program that is funded by the government. And these are usually very supported. They're usually stringently looked at by the government power, so they're typically reliable sources. So what about YouTube? Again, I said YouTube was a resource you could use. It's a great resource for learning. There's no doubt about that. But you have to make sure you know how to conduct your search. So you should use words like documentary, professor explains. So if you're looking up global warming, you might want to type in, for example, let me see, global warming, global warming. Global warming, or professor explains global warming. You're also going to want to look for tags such as education, scientific data, and again, also making sure that those numbers are accurate. Let's go back to present. Wikipedia is not a reliable source, at least not all the time. So if you can go to Google, type in global warming, and you find some authors, for example, that you can look up. If they have their expertise verified, meaning they have a college degree or been out in the field, you can also use that author's name to look up articles that are outside of Wikipedia. The source has to be reliable, so double check your sources. And final note, check your domain. If the website looks like it's trying to sell you something, find another one, don't bother with it. Find articles with plenty of diagrams or charts, such as NOAA, for example, in our previous video. Find articles that quote numbers and experiments. Be able to verify whether or not you're reading this from a source or a person with a reputation for accuracy and knowledge. And do not just copy and paste from your articles. Like in our hydrologic video before, if you need to jot down a few words and sentences before writing your summaries, feel free to do that. Do not be afraid to show your work. So with that,